have our learner question for the day here. One of two learner questions. But first, let's meet the person asking the learner question. Hello, Aussie, how are you?
Hi, I'm fine, and you?
I'm very well. What's your name? Where are you from?
My name is Anita Sluta. I'm from Vanabelbach, and I'm currently doing grade 12 at Sula Secondary School.
I noticed that in Tula Secondary School, there's a lot of Sotho-speaking people and Xhosa-speaking people. Is it like that, Vel?
Yes, it is like that.
That's very interesting and a very interesting mix. And in your community, do you speak, which language do you speak?
I speak both Sotho and Xhosa.
Very well.
Yes.
Chin Sande Qalel.
We're in Qalel.
All right. Please ask our teacher in studio what your learner question for today is.
My learner question for today is, what is a reflex arc?
What is a reflex arc? Please help us out with that.
Right, what is a reflex arc? Well, if we have a proper textbook definition, we're looking at the neural pathway that an impulse will take when a reflex action takes place. Now that's a whole lot of words. So I think to make this very clear to you as to what a reflex action is and what the reflex arc is, we need a little bit of a demonstration, boy. All right. Now, Kayla Wazi, what did you do when something as painless as a piece of cotton wool was coming your way? What did you do?
Felt frightened.
You felt frightened,
Yeah.
okay? You pulled away. What else did she do, Alston?
I reacted.
She reacted. Did you also react? And,
Yes.
and you weren't even under the threat of Mbui's dangerous cotton wool balls. All right, so you reacted, you got a fright, you pulled away, and your eyes, even though you couldn't see what was happening, your eyes blinked because you didn't realize that you were getting a cotton wool ball thrown at you. Your body didn't even have to think about it. What was happening there is your body was reacting to a threat coming towards your face. And usually when we have a threat coming towards our face, we want to blink our eyes because what happens if it's sand that's being thrown in our eyes, or there's something that's going to hurt us or cause damage to our eyes, which are very, very important parts of our body and our whole nervous system, we need to protect it. So you draw away and you're actually ready. Did you get a fright?
Yeah, of course.
Did you want to hit him or something?
No, man. No.
All right, so what we saw with how Lwazi reacted was a reflex action. So now we've got to say, if that was the reflex action, what is the reflex arc? Now the reflex arc, if we have a look at our definition again, it's the neural pathway that an impulse will take when a reflex action takes place. So our reflex actions, getting thrown in the face with some sand or some water, our brain is not trying to determine, oh, it's a simple piece of cotton wool. We're not even letting our brain in on the deal. We are reacting to it before we can become damaged. So other reflex actions, somebody giving you a fright, or moving from a dark room into an area where there's a lot of light, putting your finger onto a pin or onto a hot plate. And maybe some of you have been to the doctor where the doctor has to test your reflexes to see if there's something wrong neurologically with you. And Alston, we were talking about this earlier, and what happens when the doctor hits your knee?
Yeah,
Yeah, and what happens to your knee?
it flicks.
It flicks outwards, and that's another example of a reflex action. So what is happening is that these actions are taking place spontaneously in an involuntary manner without you even thinking about it. Your brain doesn't have to, gee, do you think the sand coming towards my eyes is going to damage them? The brain isn't even thinking about that. Your body is reacting without the brain becoming involved. So usually we would say that the brain is not involved in a reflex action. It is simply the spinal cord. So what happens? We haven't got anyone throwing cotton wool balls at us, but in our picture here we've got a candle and it's burning somebody. So what we have is, and I'm going to ask you guys about this, so pay attention. We've got something called a stimulus. And in this case, our stimulus is severe heat. Now we know that that is going to damage the hand, the skin, and the body doesn't want this to happen. And so in your skin, you have certain receptors, and the receptors that are going to be involved, particularly in this case, are going to be heat receptors as well as pain receptors, right? Very often two sets of receptors work together. Sometimes it's going to be heat and pain. If it was you putting your hand on a hot plate, heat and pain. But if you're getting pricked by something, it's going to be pressure and pain. The receptors then send a message via a very, very long nerve, one nerve that goes all that way. That is called the sensory neuron, and it's easy to remember that because it's sensing the stimulus. And the sensory neuron is one very long neuron that goes to your spinal cord. All right, this is our spinal cord, and in the spinal cord we meet another little neuron, that's this little green one, which is called a connector neuron, which is a very simple name. It connects the sensory neuron to another neuron, and we have this other neuron making a slightly different path, and it ends up in the muscle, and the muscle is going to be stimulated to move, all right? And that neuron is going to be called the motor neuron. Easy to remember because we've got sensory neuron with the stimulus, motor neuron with the muscle. So it's easy to remember. Now, in your case, Lwazi, when you had the cotton wool ball thrown at you, you pulled away, and that was the muscular reaction to what was going on. All right? So the stimulus was the cotton wool ball coming to your face, your eyes shut, you pulled away. Immediately, there was hardly a gap. And that tells you just how fast that neuron sends the message to the spinal cord, back to your muscle, because you feel that it was almost an instantaneous kind of reaction, and it's so quick, right? It is incredibly fast. It can't afford to be slow because it can't allow you and your body to become damaged. All right, so have you understood the example that we've done here? Are you ready to help me with some words, taking it through this reflex arc? First thing that happens, sensory organ stimulated, whether it was your eyes or your hand from being burnt. Do you remember what happens next?
It is the receptors. Receptors.
The receptors, that's right. Receptors. And can you remember the name of the neuron that takes the message to the spinal cord?
It's a sensory neuron.
Sensory neuron. Very good. The sensory neuron receives the impulse and carries it to the spinal cord, right? We don't have to worry about the brain or anything. Here's another term for you to remember, because sometimes you'll see this term in your textbook. The sensory neuron is often called the afferent neuron. Afferent simply means bringing something towards something else. Then the sensory neuron entered the spinal cord. Can you remember the name of the next neuron that it
Motor neuron.
before the motor neuron?
It's the
Connector neuron. Do you remember we had a connector, first of all, and then, quite correct, Lwazi, we had this connection to the motor neuron, and what was the motor neuron going to stimulate? The muscles. Excellent. The motor neuron then carries the impulse to the muscles or some kind of effector organ to bring about a motor response or a muscular response. And your textbooks might show you that the motor neuron is sometimes called the efferent neuron. Efferent meaning leaving. So afferent approach, efferent exit. Just two terms that you might see in your textbooks. What we need to remember here is that the arc, that is the neural pathway, the action is the actual result of what the nerves are telling you to do.
We have a learner question namhlanje coming from one of the learners here at Tulo Secondary School in Bophelong, which is just close to Vanderbijl Park, not too far from Sasolburg. I saw things burning there. Aren't you afraid that maybe that place is going to explode one day and then?
No, not at all. They assure us of safety.
Assure you of safety.
Yes.
So you do sciences at your school, eh?
Yes, we do.
All right, and you live very close to something that is involved in, well, I'd say chemical engineering and the production of fuels and such. Not, which career path do you want to take when?
I want to take the electrical engineering career path.
All right, interesting stuff. So, what is your learner question for our teacher in studio today?
My learner question for today is, why do we have reflexes?
I almost answered him. Why do we have reflexes? I'll sizeke with t-shirt.
Why do we have reflexes? You know what? Before I answer the question, I'm going to ask Lwazi and Alston if they can possibly give me a little bit of an answer there. From your experience of having a dangerous cotton wool ball flung at your face, boom, what do you think the reason is for reflexes?
Probably, I would say it's preventing the damages, or like it might be like being afraid to raise those fears. So you'd rather have that thing punching onto you, but not saying that. Yeah.
Absolutely. All right, she's hit the nail right on the head there. The reflex action is the result, remember, of the reflex arc, and it's fast. It's very fast because the nervous impulse didn't have time to travel to the brain to be interpreted and then go to the spinal cord. Do I have to think about closing my eyes for this dangerous stuff coming towards my face? You haven't got time to think about it. That little connector neuron that we spoke about earlier, that tiny little connector neuron is like a shortcut. So instead of information coming in, going up to your brain, back down to the spinal cord, then to your arm to pull your arm away from damage or to close your eyes. Instead, the connector neuron is like a little shortcut, and it makes the reaction so much faster than what it would normally be, as Lwazi says, in order to prevent damage. Here's another kind of reaction, a reflex action that is often spoken about in exams and in tests. So this is something you might have even seen in your textbook, and that is the pupillary reflex. You're in dim light, possibly in your room, going to sleep at night, and you open your eyes, you're able to see in that amount of dim light because your pupil is very, very large. So if we have a look here, there's a dilated pupil, which means that the pupil is open very wide to allow whatever light is available into your eyes. Somebody walks into your room and switches on the light, and immediately you blink and you close your eyes because that amount of light going through your wide open pupil is going to possibly damage your retina. So you want to shut down that pupil, and that's where you get the contracted pupil coming down from large to smaller to only allow a certain amount of light in. So the reflex action that takes place is possibly shutting your eyes, but also contracting that pupil. And all of these reflex actions that take place, as Lwazi said, are to prevent damage. And your biggest cue to stop the damage is, of course, pain. Your body doesn't want to have pain. So the pain is a signal, a bright light is a signal, something coming towards you is a signal to do some kind of reflex action so that you don't cause damage to your body.
Keleza Nathi.